Here, in ultra-modern laboratory buildings, work scientists in and out of uniform. They work with the incredibly complex equations of nuclear physics, which derive from Einstein's famous relationship of mass to energy. These cryptic figures, programmed into lightning-fast computers, are the theoretical base upon which these scientists, together with those of the Atomic Energy Commission, can build nuclear weapon safety. Know how these explosions can be produced, the general principles of nuclear explosions.
Any explosion is the result of a very rapid release of a great amount of energy. Conventional explosions result from the rearrangement of whole atoms in some explosive material. On the other hand, nuclear explosions result from the rearrangement within each atom. The atoms of uranium and plutonium are among the heaviest. Heavy because the nucleus of each atom contains large numbers of the fundamental particles called protons and neutrons. When a free neutron hits this nucleus, it splits into two parts, releasing more neutrons which may go on to split other nuclei. The resulting fission products become highly radioactive, emitting the long-range and dangerous gamma rays. The split nucleus weighs less than the whole one, and this difference in weight is released in the form of energy, nuclear energy. After fission, harmful gamma radiation. Before fission, innocuous alpha radiation. To build up a nuclear energy release, the fissionable material must be of a certain size, shape, or density. Then one of the neutrons escaping from a split atomic nucleus will, in turn, split another, and a chain reaction is set up. The mass is now releasing nuclear energy, but not quickly enough to cause a nuclear explosion. This condition is called critical. If the mass is now suddenly increased, so that more neutrons are trapped each time an atomic nucleus is split, a multiplying chain reaction is maintained. Now the mass is supercritical, causing a nuclear explosion. Density of the fissionable material can be as important as mass in building up a nuclear explosion. The same sphere can be compressed so that the atoms are closer together and neutrons split more atomic nuclei, making the smaller mass critical. If compressed still more, a multiplying chain reaction sets in, causing the mass to become supercritical in a nuclear explosion. Another kind of nuclear weapon is the implosion type. It compresses the fissionable material to greater density to make it supercritical. To do this, the sphere is enclosed by a shell of ordinary explosive designed to direct its explosive force inward. This effect is called implosion. The detonators attached to the explosive are connected to a complex firing device which can fire every detonator simultaneously. When all the explosive is detonated simultaneously, the nuclear material is compressed into a supercritical mass which results in a nuclear explosion.